When you boil it all down, physics is really about answering two super simple questions: where and when. Today, we are going on an incredible journey to the absolute edges of reality to see how scientists built the cosmic clocks and rulers they need to measure everything, from the age of our planet to the blink-and-you-miss-it life of a subatomic particle. I mean, really think about that for a second. How would you even start? We're talking about things that are either so incredibly vast or so unbelievably fleeting. Answering these questions has led to some of the most brilliant and ingenious ideas in the history of science. So where does a story like this even begin? Well, it all starts at a moment in history when we stopped just, arguing about the world philosophically and started actually measuring it to figure out how it works. And for that, we look to Galileo. Before him, motion was something philosophers debated, but Galileo, he decided to run an experiment. He rolled a ball down a ramp, and get this, he used his own pulse as a stopwatch. And in doing that, he found this simple, beautiful mathematical pattern. And that was it. That was the spark. For the very first time, someone turned a physical observation into a mathematical equation. It was the birth of physics as we know it, the idea that you can understand the universe by measuring it. Okay, so if we're going to measure things, we need good tools. Let's start with time. We're going to climb what you could call a cosmic ladder of time measurement to see how physicists chase down the perfect clock. What's so interesting here is this sort of philosophical problem right at the start. How do you know if your clock is accurate if you don't already have an accurate clock to compare it to? Well, the solution is to find things that happen over and over again. You check one repeating event, like sand falling in an hourglass, against another one, like the sun hitting its highest point at noon. And when they both seem to agree day after day, well, then you start to feel pretty confident you're actually measuring something real. But to measure really, really tiny slices of time, a pendulum or an hourglass just won't cut it. We need something way faster, like an electronic oscillator. And the method here is just brilliant. You take a really fast signal you want to measure, and you overlay it with a slightly slower one that you already know. By counting how the waves match up and drift apart, you can slice time down into trillionths of a second. It's like having a microscope, but for time itself. So we've built this incredible time microscope, right? But there's always a but. Some things in the quantum world happen so ridiculously fast that they're born and gone before our best clocks can even tick once. So now what do you do? This is where scientists just get so clever, they basically change the rules of the game. If you want to measure the life of a particle that's around for just a quadrillionth of a second, a clock is totally useless. So they don't use one. Instead, they let the particle fly. They measure the teeny tiny track it leaves behind, and then they divide that distance by its speed, which is darn close to the speed of light. And the idea here is just incredible. When your stopwatch is too slow, you use a ruler to measure time. Okay, so we've looked at the impossibly fast. Now let's climb to the other end of our ladder. How do we measure the unimaginably slow, the immense, deep time of geology? For deep time, ticking clocks are no good. But luckily for us, nature has its own kind of timekeeper, radioactive decay. See, certain elements decay at a perfectly steady, predictable rate. We call it their half-life. So by looking at a rock and measuring the ratio, how much of an element like uranium is left versus how much has already turned into lead, we can essentially rewind the clock and see when that rock first formed. And using this exact radioactive clock method on ancient rocks from Earth, and even meteorites that have fallen from space, scientists have figured it out. The age of our planet is a staggering 4.5 billion years. So here it is, the full ladder of time. We use the Earth spin for our everyday lives, pendulums for seconds, those bizarre little particle tracks for the quantum realm, and the slow, steady tick of radioactive decay to read the history of the planet. Every rung is a different, brilliant solution for a totally different scale. All right, we have our clocks. Now for the other side of the coin, the rulers. How in the world do we measure distance from across a room to the very edge of the universe? So for our own cosmic backyard, we can start with stuff you might even remember from school. We can use basic geometry, triangulation, to figure out how far away the moon is. For planets that are a bit further, like Venus, we can literally bounce a radar signal off of them and just time how long it takes for the echo to get back. That gives us a rock-solid ruler for our entire solar system. But what about stars that are so far away that triangulation doesn't work? We need a new ruler. So astronomers invented one. They figured out that there's a direct link between a star's color and its actual, true brightness. So now you can look at a super distant star, check its color, know how bright it's supposed to be, and then, based on how dim it looks to us, you can calculate how far away it is. It's an absolutely brilliant workaround. We've reached for the stars. Now let's do a complete 180 and journey inward, down to the mind-bendingly tiny scale of inner space. So here's a huge problem when you're trying to measure tiny things. You literally can't see anything that's smaller than the wavelength of light you're using. It's a fundamental limit. To get around this and see an atom, which is around 10 to the minus 10 meters, physicists shoot X-rays at a crystal. The X-rays bounce off the atoms and create a pattern. And by analyzing that pattern, they can work backwards and map out the entire atomic structure. But to measure something like a nucleus, which is 100,000 times smaller than the atom, the ruler has to get even weirder, even more abstract. What physicists do is fire a whole stream of particles at a thin piece of foil. Most of them just pass right through the empty space in the atoms, but every now and then, one hits a nucleus. And by simply counting how many particles get blocked, they can calculate the size of the target. It's like trying to figure out the size of a dartboard in a pitch-black room by just randomly throwing darts and listening for the thud. And there you have it, our complete ladder of distance. It starts with simple meter sticks for us, stretches out into space with geometry and light, and then probes the heart of matter itself with pure probability. Each rung of the ladder lets us map out a whole new piece of our reality. So we've built these two incredible ladders, for time and for distance, reaching to the biggest and smallest scales imaginable. But what happens when you get to the very last rung? This is where things get really, really weird and profound. It turns out that a perfectly precise measurement of anything is actually impossible. Because at the quantum level, particles also behave like waves. There's a fundamental fuzziness baked into the fabric of reality. The universe itself forces you to make a trade-off. And this is the famous Heisenberg uncertainty principle. It says that the more precisely you know where something is, the less precisely you can possibly know its momentum or where it's going. And, to bring it all back to our clocks, the more precisely you know when something happened, the less you can know about the energy of that event. There is no such thing as a perfect ruler, and there is no such thing as a perfect stopwatch. It's a law of nature. Which leads us to one final mind-bending thought. We've managed to measure time down to about 10 to the minus 24 seconds. That's the time it takes for a beam of light to cross a single proton. But what about smaller than that? Is there some kind of tick-tock happening even faster? Or have we finally reached a point where the very idea of time just stops making any sense at all?